Configuring OSPF route. It's not difficult if you have done some routing protocol configuration earlier. There will be slight difference, but configuration is almost similar to EIGRP. So when we say EIGRP, we say router EIGRP and then the autonomous system number. Here, instead of autonomous system number, we are going to give process ID.
Okay.
The difference is autonomous system number is globally significant, meaning the autonomous system number is always sent in the update packets, hello packets, and every packets of EIGRP. And this autonomous system number in EIGRP must match with the neighbor if they want to form neighbor. But process ID is local to the router. It will not be shared to anyone. It is local to router. Then why do you need this? It is just to identify the process that is running on behalf of OSPF. OSPF is identified locally using process ID. It's the process ID. It is not the autonomous system number. So process ID is for processing locally. You need a number to identify the protocol which is running. For that we have process ID. Now, can we configure OSPF without a process ID? Answer is yes and no. In some versions, like XR devices, there is no need for process ID.
Okay, did not know.
But in iOS routers, you must mention process ID. Process ID is to identify process. Then on XR device, what will happen if you don't assign a process ID? No process ID itself is an ID. Without any process ID, when you configure, there will be some value to say no process ID. That value itself will be used as the process ID. Now, why do we need process ID? When we run more than one OSPF instance on the same router, when you run more than one instance on the same router, what is the use case? We have VRF. What is VRF? It's a virtual routing and forwarding, which is a virtual router on the inside the physical router. When you have virtual router inside the physical router needs one OSPF. The virtual router needs another OSPF. So you need two OSPF. How do you differentiate this OSPF and that OSPF? With the help of process ID. Do not think too much about VRF now. We will be learning about VRF later when we are in MPLS class. So now, focus only on OSPF. OSPF can have more than one place in the same router to run. One in the physical router, other one in the virtual router. To differentiate physical router OSPF and the virtual router OSPF, we need process ID. Next, there are two ways in which you can run OSPF on the interfaces. Number one, when you say network and put a network that matches the interface, all those interfaces will run OSPF. The other one is go straight to the interface itself and say, hey, this interface belongs to OSPF process ID 1. and then this interface will also be a member of this area ID. So instead of we giving area ID, wildcard mask, network, and a router mode, you can go straight to interface. This is considered to be an optional method, but this is the method I always do. I prefer. So then there is no need for writing wildcard mask. When you go under router mode and enable OSPF, we need to specify wildcard mask,
Okay.
which is not needed when you do under the interface. Both are good. See, for example, here on router B, there are two networks. One is 10.2.1, another one is 10.64.0.2. The mask here may be 16, they have not mentioned. Here may be 16. But you see, when they write the wildcard mask, they're matching all 32 bit. What is this meaning? It means the interface that has got this address will be the member of OSPF process ID 50 and belong to area 20, area 0. So any interface that has got this address, all 4 octet should match. That's why they have put 0000. If this address matches, then that interface is a member of area 50. Sorry, that interface is a member of process ID 50, area 0.
Okay.
So this is not mandatory to do like this. Instead of this, what they can do is they can do like this. Here, even though it is 10.64, here it is said simply 10. If you find 10 in the first octet, which is matching here, you need to put that interface in OSPF process ID 1, area 0. So this interface is now member of area 0, OSPF process 1. Now, when do you need to do this way? When should we use this type of wildcard mask? If I do not want to run OSPF on this link, for example, I should not put simply 10. If I put 10, both will match. So I should be very specific like this. Only if all this 4 octet is this will be the member of area 50. Sorry, OSPF process 50 and area 0. Which means OSPF will run only on this link, not on the other link. Anyway, for this example here, it's not necessary to do like this. It's two separate lines. Two separate
Okay.
lines. Not necessary. But again, one more thing here this page teaches us is a configuration for both LAN broadcast and WAN point to point is same. There is no difference. There is no extra configuration. There is nothing extra needed. Both LAN and WAN configuration is same. And what else we learn from here? The process ID can be different. You see here 1, here 50, nothing wrong because they are local to the router. They are not going to be advertised to the adjacent neighbors. This process ID will not be shared along with the hello packets or anywhere. Multi-area. We have learned earlier that the area ID should match in order to form neighbor. So, because this belongs to two different areas, you must specifically run OSPF for the subnets, not global like what you see here. This is any interface that has got 10 belong to OSPF1 area 0. I cannot say that here in this router because in this router, this particular 10.64 is area 0, 10.2 is area 1. So I need to do separately. Or I can mix like this. You see here, this is a classical method 10.64. This is an optional method. Going straight to the interface and say, hey, this interface belongs to area 50. Sorry, OSPF process 50, area 1. Whereas here, if you see, same process area 50, we are doing in the classical way. You can mix, nothing wrong. That's what here it means. You can mix both. Do you have any question on configuring OSPF?
No, no, sir.
All right. Now, do you want me to do a lab before we go to the next topic, or is it okay to go to the next topic?
No, I understand this quite well. No, no lab needed.
Wonderful. Let's go next. Router ID. You see, OSPF is not a TCP or UDP protocol. So they need an ID to be identified. TCP or UDP protocols, they got some port numbers to get identified. But this is a layer 3 protocol. OSPF is a layer 3 protocol. They don't have any port number. So they need an identification. Every router needs identification. They need to be uniquely identified so that they can say, hey, I'm coming from so and so router. This uses IP number 88, but that is not going to be an ID for the devices. If you capture OSPF packet, you will not see any TCP or UDP layer. If you have TCP or UDP layer, you will have port numbers. Source port number, a random port number, destination port number, some number. OSPF is a layer 3 protocol. So what is used to identify a device? So that the device can say, I'm coming from Robert, I'm coming from Jay, I'm coming from so and so. There should be some ID for each route. The router
Right.
has got IP addresses on the interfaces. The routers have got IP addresses on the interfaces. So OSPF is designed to use one of the IP address as the router ID if we don't specify one. See, you can specify every router a unique ID using this command. But when you don't do that, it automatically picks the IP address. It picks the highest IP address from the active interface at the moment when you configure OSPF. Repeating again, it's important. At the moment, meaning when you configure OSPF, it'll see what are all interfaces and what are all IP addresses on those interfaces. First preference it will give to loopback interface. At the moment when you configure OSPF, if there is loopback interface address will be picked the highest IP address among the loopback interface. If you have made more than one loopback interface, it's going to pick the highest IP address from the loopback interface. If you don't have loopback interface at the moment of configuring OSPF, I repeat, you may configure loopback interface later, but don't expect that to be the router ID. At the moment of configuring OSPF, if there is loopback interface, it's going to pick the loopback interface address as the router ID. If no loopback interface, the highest IP address on the physical interface is going to be picked up. And if you don't,
Understood.
now if you don't have loopback interface, it's going to pick from the physical interface. Later, if you give a loopback interface with an IP address, or if you configure router ID using router ID command manually, it will not be used immediately if already a router ID from the physical interface is taken and shared with the neighbor. I repeat, if already there is a router ID, that router ID is already in use. Used for what? Used for advertising to the neighbor saying, it's me talking to you. So it has already started using the name. OSPF has started using that ID, which is copied from the physical interface. After it shared, for example, you have shared your name, Robert. After sharing your name to the government, to the records, in the hospital, in the school, in everywhere, it's Robert. After sharing the name, if you wish to change your name, it's very difficult. You need to start from the beginning. You need to go back to the hospital, trace back the hospital where you were born, and say, hey, this was me. Can you give me a copy of my birth certificate? And refer that to the government and say, from now onwards, I'll not be called as Robert. I'll be called as the Son of God, Robert. Something like that. So you want to change the name. After sharing with someone, if you change the name, it's not going to be active because the old name is already famous. Likewise, at the moment, whatever is available, it is going to use. Later, if you change or if you provide a loopback interface, it's not going to take. It will take, but it's not going to use it actively. It will continue using the old name, old router ID, and only when you restart the OSPF process, the new ID that you are expecting will be active. Any question on router ID?
No, no, sir.
Right. So to pick up a router ID from a loopback interface, is there a need for OSPF to run on loopback interface? Question. Do we need to run OSPF on loopback interface in order to be used as a router ID?
No, you don't need to.
Not at all. Correct. Whether OSPF runs or not, the loopback interface address can be used as a router ID. So the neighbors, when they receive the update with the router ID, they are not going to see whether I'm able to ping the router ID. No, neighbors are not going to check whether the router ID is pingable. They, the neighbors will simply use that ID as the ID only. No need to be a routable address. So loopback address can be used. It need not to be there in the OSPF table. Um, so it need not to be advertised. As a result, it saves the address space in OSPF. It need not to be a pingable address. If you're advertising that network, it is going to be in the OSPF table. It will use some space. It can be pinged from the other routers. That's the difference. Now, as I said earlier, if OSPF process is already running, the router must be reloaded, or you need to kill the OSPF process and reconfigure or reinitiate the OSPF process, refresh the OSPF process by typing the command clear IP OSPF process so that the new loopback address will take effect. As I said earlier, if already the router ID is in use, if there is some router ID in use, the new router ID will take effect only when you restart the OSPF process, either by killing the OSPF process or by reloading. When you kill the OSPF process, it dies and comes back. When it comes back, it takes the new one. Now, this is the way that we configure router ID manually. Go in the router
Okay.
process and say router ID and then give an address. As I said earlier, if you want a new address to be the router ID, when there is already a router ID in active, if you want to take the new router ID, then you need to wait for the next reload, or you have to clear the OSPF process by typing this command clear IP OSPF process. It's going to ask you a confirmation. Are you sure you want to do this? You must acknowledge if you really want. The reason why it is asking a confirmation when you hit enter, It's going to ask you confirmation. The reason why it's asking confirmation is it is going to kill the OSPF process. When it kills in this router, it's going to impact the other routers. So the impact is going to be at least to all the routers within the area. To avoid that, you may wait for a maintenance window, or if you're okay with the disturbance, interrupt, impact, then you may say yes. Some verification commands, when you type show IP OSPF, it's going to show you on this router there's a OSPF process called 50 running, and there's an ID taken 10.6405, and you can also see that number of areas in the router is 2. Okay, this is an ABR. Yeah, there is area 0 and area 1. This is an ABR router.
Right. Right.
Show IP protocol, as usual, when you configure any routing protocol to verify whether the routing protocol is working fine, we used to use this protocol. Show IP protocol will display all the routing protocols that you are running on this router. Show IP protocol. Show IP route OSPF process. If you are willing to see one particular OSPF route, see if you are running more than one OSPF, if you are running more than one OSPF, and I want to display only those routes learned by OSPF process ID 1, then I can say show IP route OSPF 1, show IP OSPF, show IP route OSPF 50.
Okay.
So we will very clearly know from where, from which interface, from which process I learned this. So when you run more than one OSPF, you need this, but very less use case for running more than one OSPF without VRF. This is without VRF. Very less chance. Next is you can also see the status of OSPF power interface. Show IP OSPF interface. And then if you give a name like 0/1 or 0/2, put name, the interface name, it's going to display whether OSPF runs or not. If it is running, what is the router ID to which it belongs to, area ID it belongs to. Is there any router?
Okay.
Is there any router forming neighbor with this interface? Adjacent router and so on.
Okay.
Alright, next is show IP OSPF neighbor, which is going to show you the neighbor information, whether the neighbor is a full adjacent neighbor or two-way adjacent neighbor, or whether the neighbor is a point-to-point or a broadcast, is neighbor a DR or BDR or other. All informations can be seen, all these informations can be seen by typing show IP OSPF neighbor. Okay, this is a sample output show IP route OSPF. It shows that there's only one OSPF running, and this is the route it has learned via OSPF. When you say OIA means inter area, meaning this is the route, this is the destination, which is in next area, not in the same area. This destination is not in the same area where router A is. This destination is in some other area, inter area. O simply means OSPF, IA means inter area. Route coming from other area. And what do you see here is 110, which is the administrative distance of OSPF. And what you see here is the cost, auto cost, calculated by using bandwidth. You can also specify the cost, but here it is auto cost using bandwidth.
Okay.
When you want to specifically see one particular interface OSPF status, then you type show IP OSPF interface name. It shows that the interface is up, the line protocols are up, this belong to area 0, this is the IP address on the interface, this is the mask. And it is also a broadcast type, which is a LAN type. And the router ID that this router is using is this. And this is a DR other router. It's not DR or BDR, it's DR other router. And this is the designated router address. And the timers are 10 and 40. So if you wish to know,
What I noticed though, it doesn't see, it doesn't, with this command, I do not see the neighbor.
no, you will see neighbor down here. You see, neighbor count is 1.
Okay, and this is, okay.
Adjacent neighbor count is 1. There is one neighbor, and this is that neighbor IP address. And the neighbor is a designated router. All right. So this is locally dot 1 at DR other. This is DR. When we type show IP OSPF neighbor, it's going to show you the list of neighbor. And if you notice here, the priority is set to 0. The default priority is not 0. Here the priority is set to 0 on fast Ethernet. So this cannot become a DR or BDR. And then we also see the status full state. Right. And when you type the same show IP OSPF with a detailed command, it'll show you much more detail. You see this particular neighbor learned via this interface belong to area 0, which is not seen here. The area information is not seen here. And the neighbor's priority is 0, it's full state. So far 16 times the state changes happen. And the DR router is this, the one with this address is the DR router, there is no BDR router. And there is another neighbor here, similar information. There's no DR or BDR because it's a serial link. Right. This was an easy chapter for you.
Can you go back? Can you go back to the all right, right here where it says neighbor ID. I give you that neighbor ID, and then over here where it says address. Where is the neighbor, and where is the router that has the neighbor?
See, this is the IP address. And this is the router ID. In this router, it happens to be the same. When you don't,
this is router ID.
Yeah.
Okay.
This is how the neighbor is identified. This is how the neighbor OSPF ID, OSPF neighbor is identified. This is the interface address from where the update has come. The neighbor negotiation has happened. This is the address from where the neighbor negotiation happened. In this router, it is the same because there is no other interface on the router.
Okay.
Right. So
yes, sir.
Most of the things in this chapter was a known story for you. It was an easy chapter. There's some verification commands like show IP protocol, show IP route OSPF, show IP OSPF, show IP OSPF neighbor, show IP OSPF interface brief. There is one command which is missing here. It's a nice command, show IP OSPF interface brief. After interface, you type brief here.
Right. I'm familiar with that command.
Yeah, it's well known. OSPF network types. You see, OSPF has got three different types of network. Three different types of network. One is point to point, which you already know. We got serial link. On the serial link, there cannot be more than one router connected on the other end. So it's point to point. In point to point, there won't be a DR BDR needed. Is there any need
Right.
for a DR BDR? No, because it's just two router. There is no need for DR BDR. This guy gives to that guy gives to this guy. Finish. There is no chance of forming loop or duplication. So there is no need for DR and BDR.
Right.
Single pair of router using a WAN interface. Next is the broadcast. This is the place where you will have more than one router to form neighbor. That's why it is multi-access. In this environment, there is a need for DR-BDR election.
Right.
The third one is non-broadcast multi-access. This is an outdated story. The third type is an outdated
Right.
story. Whenever you got a non-broadcast environment in the middle between two routers or
Mm-hmm.
between more router, you may have like a router 1 here, router 2 here, router 3 here, and in the middle there is a non-broadcast environment like frame relay.
Okay.
In that environment you can have 5 different modes, 5 different ways of forming neighbor, 5 different 5 different behavior of OSPF you can have. You'll see 5 different behavior, and you can pick one of them as the behavior that you want according to your wish. So what I'm trying to say here is there are 5 different modes. They don't behave same. That's why there are 5 different mode, 5 modes, and whichever suits your environment you can keep. Now these 5 modes, if you learn, you may use any one of them even in this environment. I remember before 2 classes you were asking, can I go to a WAN interface and configure it as broadcast or broadcast interface and configure as point to point? Yes. Likewise, you can configure any of these 5 more under the interface. That's why you're going to learn this. Even though we don't have this frame relay, even though it's an outdated one, we don't have a non-broadcast environment now.
Right.
We still learn this just to understand this 5 mode so that you can use any of this mode in your point-to-point or your broadcast environment, right? So NBMA mode, the purpose of we going to learn is to understand that 5 mode so that I can use it in a broadcast environment or point-to-point environment if I wish to have 5 modes.
Okay.
But in Cisco only we see that 5 mode. The other vendors they don't have 5 mode. They got just two modes.
Okay.
Only two modes. According to the RFC, there is only two modes. In Cisco, we got 5 modes. You know about point to point. When you got serial wire, you consider
Right.
OSPF considers it as point to point network type. You don't need to say, hey, I have a point to point. It automatically senses. It automatically senses that he has got a serial link. He has got the encapsulation as HDLC or PPP. See, when you have serial link on Cisco devices, the encapsulation type in layer 2 will be HDLC. OSPF can sense it. You can also change it to PPP. Now, when it is HDLC or PPP, automatically OSPF will say the network type on this link, the OSPF network type on this link is point to point. You may have point to point in NBMA mode, like frame relay and ATM. By
Right.
creating sub-interface, you can do that. I'll show you this example later when we go to NBMA modes in our next class. Now, I just want to say that this point-to-point is not only on the WAN link, the serial link, it is also on the frame relay and ATM environment. Now,
Okay.
the third point, if you see here, there is no need for DR and BDR election.
Correct.
It's only two routers. And next is, you no need to say this is a HCLC running serial interface. They are auto-detected. The interface type is auto-detected. And we
Okay.
saw in the previous class that there is only one multicast address needed for point-to-point, which is 224.0.0.5. There is no need for 6 because we don't have a DR. Only the designated
That's
router needs
correct.
6.
That's correct.
Next is broadcast network type or multi-access broadcast network type. Whenever you got more than 2 routers like this, if you see here, there is a switch in the middle. The red line indicates a switch, and there are 5 routers connected to the same local area network. Because you got LAN, Ethernet is the technology. There is no more token ring, it's a very old one. So we got Ethernet, and you got more than one router as a neighbor to be formed. So there will be a duplication of update. To avoid duplications, we have DR BDR election. BDR
Right.
DR need to be selected. Based on the highest priority, they are selected. If there is no priority, if there is a tie-in priority, then they are going to compare the router ID to decide the DR BDR roles. And we also saw in the previous class that every router will form full adjacency with designated router and backup designated router. Full adjacency. Now packets to DR and BDR is 224.0.0.6. Packets from DR to other routers is 5. Are you clear with this one, which we also discussed in the previous class? This last 2 points.
Yes, I'm clear. I do understand. Yes, I do.
Nice. So let's move on to this one. You see here, this shows how the election process goes. The DR BDR election process. The DR is picked up based on the priority here. The router with a high priority is becoming DR. It always prefers the priority. If only when there is a tie in the priority, to break the tie, it will use the router ID. So the second biggest priority router has become a BDR, and the C router will never get a chance to become a DR or BDR. The reason is when you say priority 0, you are saying do not participate in election. Do not participate in election. So this will be always other router, DR other. Now if this dies, what will happen? I'm asking a question.
The DR will become,
This will become,
the BDR will become the DR.
Yeah. Now,
and then an election will run for those two.
Those two
right
have
there.
got same priority. Then which will be the BDR?
The one with the highest
Router
router
ID.
ID.
Let's say the router ID of this is 2222 and this is 1111. So B will become the BDR.
2222. Right.
Okay. Now what happens is this DR, all the DR is coming back again. What will happen?
It will not, it will just stay as a regular router. It would not replace that BDR or the DR.
Yeah. It will continue to, it will become DR other. DR other. Neither can become a BDR or DR because it is non-preemptive. The election process is non-preemptive. Once elected, elected. The others, whatever the superior priority or the router ID they may have, that doesn't matter. They have to wait for the re-election. So DR election is non-preemptive. That is good actually. If it is preemptive, then every now and then some new DR will come. DR means they're supposed to know everything about that land. If new router comes, then there won't be information. Say for example, in a project you have a project manager. Every now and then if the project manager keeps changing, then very difficult for the project to get completed because the new project managers, they do not know what has happened when the old project manager was there. The improvement in the project, nothing. Likewise, DR collects the information from every other router and maintains it, so it cannot be keep on changing. DR election is non-preemptive. Now, we saw that according to OSPF, the one with the high router priority should become a DR. How do you set priority? We go under the interface and we say IP OSPF priority and then the number. The maximum is 255. It can be anything between 0 to 255. The maximum is 255 and default is 1. As I said earlier in the previous page, if you put 0 as the priority, the router cannot become a DR or BDR, meaning it will never participate in election. The router which is not a DR nor BDR are called as DR other. Now on the same router, if you have one router here this side, here this can be a DR and BDR, and on this side this can be a BDR or DR other. So
Right,
it is
because
with,
it's per
yeah,
segment.
it's per segment, per LAN, per layer 2. Right, NBMA, let's not get into it today. We'll see the next class. So what we learned in this new chapter is about the previous chapter was about the configuration, verification, and it was easy chapter for you. In this chapter,
Right.
we learned about types of networks in OSPF, in which point to point will not have any DR BDR because it's point to point. Broadcast is going to have DR BDR. Broadcast is going to have DR BDR because it's more than one router as a neighbor. So to avoid duplication, we need DR BDR. NBMA is nothing but non-broadcast multi-access. When we have frame relay environment, we consider it to be a non-broadcast. There we will see 5 modes. But though we don't have NBMA today, non-broadcast environment today, we're still going to learn 5 modes so that you will know those modes which can also be applied to a broadcast and point-to-point environment.
Okay.
Point-to-point needs only one multicast address 224.0.0.5 and there will not be DR-BDR election. Jesus, hallelujah. In multi-access environment, there will be a DR-BDR election. 224.0.0.6 is what address used to talk to DRs, and DR talking to others will use .5. If there is a tie-in priority, only then the router ID will be the decision maker of DR and BDR. If priority is set, it's going to be the priority, the one which decides the role. And priority can be easily set like this, going to the interface. All right, so we'll stop here.